Hi everyone. In the last section we were discussing on the Electricity Act 2003 and also on the National Electrical Code NEC 2011. Now we are going to discuss on the voltage standard which is prevailing in our country, and that is defined by the IS standard IS 12360, basically for the preferred voltages and frequency just to be maintained at the transmission, the generation and also at the distribution side. A lot of amendments has come into this particular IS standard. So if you read through that particular amendments, you can see what are the changes which has been incorporated. And at a certain point of time, we can also see certain amendments were kept on hold. So what we are going to discuss is what is prevailing now in our country. So from this IS 12360, the National Electrical Code has taken the standard values, and the section 6 of NEC 2011 is discussing on the standard values of voltage and frequency prevailing in India. So it defines for the single phase systems and also for three phase system. For the standard voltage is 240 volt in the case of a single phase two-way system, and for three phase system it is 415 volt, 3.3 kV, 6.6 kV, 11 kV, 33 kV and up to 400 kV. So basically this up to 11 kV, that is up to from 3.3 kV to 11 kV, it is nothing but the generation voltages, and around 99% we can say that the generation is at 11 kV. And all other voltages above 11 kV is nothing but the transmission voltages, and 415 volt is nothing but the distribution side three phase voltage. So 415 divided by root 3 is nothing but 240 volt. So this is for the AC system, and similarly for the DC system it is 220 volt or 440 volt. So from time to time we have said that there was International Electrotechnical Convention was there. In order to cope up with the IEC standard, our standard voltages was supposed to be changed from 415 volt to 400 volt system, that is 400 volt 230 volt. But that amendment to that our IS standard was kept on hold in the year 2011. So what we are having is nothing but 415 volt and 240 volt system. So even though we have that specified values, there are certain kind of bandwidth is allowed for that particular voltage levels. So that voltage level is being defined for four different sections, that is a low voltage, medium voltage, high voltage and extra high voltage. So we will also see what all voltages will be coming under low voltage, what all voltage coming under medium, high and extra high. So for low voltage it is plus or minus 6%, that is both on the lower side and also upper side it is the same thing prevails for medium voltage also. But for high voltage it is minus 9% on the lower side and plus 6% on the upper side, and for extra high voltage it is again plus or minus 12.5%. That is what is the variation which is allowable for that particular value of voltage. And next we are going to discuss about what are these low, medium, high and extra high voltage. So all voltages up to 250 volt is low voltage. From 250 to 650 it is medium voltage, and up to 33 kV it is high voltage, and anything greater than 33 kV is nothing but extra high voltage. So our generation is nothing but a high voltage generation. Transmission is again it can be coming in high and also in the extra high, and our distribution is we have our 250 volt system, the 230 volt single phase and also on the 415 volt systems. Now the frequency standard, I have taken this frequency standard from our Indian Electricity Grid Code. So with effect from the May 2010, even though our standard frequency is 50 Hz in our country, it can vary from 49.5 to 50.2 on the upper side. So these are the standards which are specified by the Bureau of Indian Standards, and that is being discussed in the section 6 of NEC 2011. So there can be a lot of amendments which is coming into picture, which we have to refer it to the highest standard book, the amendments, and see that which is the latest. And also you can also log into your Central Electricity Authority or the Power Ministry website in order to see what is the latest values, because a lot of amendments will be coming into picture in case of the standard values. Now we are going to discuss on the safety aspects of electrical systems. So any kind of electrical system design, it has to cater to the consumers by providing a safe and reliable power. So safety is an important aspect. So our system has to provide proper functioning for the use it is intended to use, and it should also provide safety to the person and also to the property against any kind of damages and the dangers. So electrical installations are always subjected to end user risk, and major one is nothing but electrocution because of the electrical shock. That is, whenever a current is flowing through the human body, so it acts as a source of danger which has a negative effect on the human body. So the end user risk is nothing but electrical shock current, and also a small spark can result in increasing the operating temperatures, which may result in burns or fire. So you can also think about the various kind of short circuit problems which has occurred in many of the shops in Kochi and also in Trivandrum and other places in Kerala. So in most of the cases it was because of the short circuit, or it may be because you are trying to dump a lot of material inside a particular room, the room temperature goes up very high. Then a small spark which may occur at any small places or a short circuit, it builds up at a higher rate, and then it will result in a fire accident in a particular premises. So safety is an important aspect, and in order to we have to incorporate a lot of protective measures. That is, it can be against the direct contact, against indirect contact, thermal effects, overcurrent, fault current, over or under voltages. So direct contact is nothing but you have to prevent a person and livestock coming in direct contact with the live parts of the installation. So from the design stage it comes into picture, and if any point of time a person comes in a direct contact, then proper protective measures has to be there. And also protection against indirect contact, that is, a person has to be protected against the possible dangers from a contact with the exposed conductive parts of an electrical installations. So there are many kind of things which is coming into picture, that is, a body of a motor or an electrical equipment, it normally it's getting earthed, it is given to the earth pin. So even though you get in contact with that body to which there is some kind of electric current passes through that, since the body is already earthed, you are getting protected away from that. So you have to prevent the fault current from passing through the body of any person or livestock, or limiting the magnitude of the fault current, or by automatic disconnection of the supply, you can protect a person from this kind of indirect contacts. So for that, the basic example is nothing but your electrical iron. The electrical iron plug point, it has 3 pins, that is, an earth pin is also there. And just imagine if any problem happens to the insulation inside an electric iron, so that time the current may pass through the body, and since the body is already earthed through the earth pin, we are getting protected from that particular electrocution. And against thermal effects, so all the electrical installations had been designed, that is, there is no risk of ignition of flammable materials, maybe due to the high temperature of the conductive parts or due to an electric arc. Now the protection against the overcurrent. So all these discussions when we are having, it is not only the persons, it is also the property which comes into picture. So overloading in a particular electrical installation cannot be avoided, and if overloading is there, then obviously overcurrent comes into picture, and it may result in a damage of a particular equipment if it is not protected properly. So automatic disconnection of the system has to be there, and also you have to limit the maximum value of overcurrent to a safe value, and therefore the property and also the person who is operating that is again protected against such kind of dangers. And fault is unavoidable. They are likely in any kind of electrical systems, and therefore you have to protect the equipment, the conducting parts which is carrying the current, and the operator also. So under any kind of faults, the system should be capable of carrying that particular fault current. And then the last one is the protection against the over and under voltages. Over voltage is more prominent in the case of lightning or switching, or when there is a fault between two lines or something. So such kind of over voltages, proper measures has to be incorporated in order to protect the persons and also the property. Under voltages, normally it may not cause a danger to the operating person, but many of the times you have an industry, if there is an under voltage, then at that particular point of time your motors will not be working properly. It may result in an overloading of the motor, or it may result in the unwanted tripping of the motor stud. So it may result in a production loss. So in order to have a reliable operation, then you should also have a protection against the under voltages. So these are the safety aspects which you have to discuss in the case of electrical systems.